Hello, in this video we're going to talk about how to solve a system of two linear equations in two variables. Sounds really complicated, but it's easier than you think. So what is a system of a two linear equation? So system in a two linear equation is given in the form of this ax plus by equals to c dx plus ey equals to f, where a, b, c, d, e, f are coefficient, x and y are variable. The system is represent the standard form. Okay, so what is coefficient? So basically coefficient is you see them as a number, such as a can equal to 4, b can equal to 5, c equals to 10, d equals to 7/8, e equals to 1/5, and then f equals to -2. They can be any number, positive, negative, fractions, decimals, they all work. So if I return it in here, I will have a equals to 4, so I have 4x plus b equals to 5, y equals to c, where c equals to 10. And then dx is going to be 7/8 x plus 1.5y equals to -2. So you've seen this before. So remember, this is a system of a linear equation. So each one of these represent a linear equation. This is a standard form of a linear equation. We see another forms in previous studies, such as y equals to 2x plus 4. This is called what? Slope-intercept form, right? This one represents the slope. This is the y-intercept. And we also have a slope point form, which is y minus 1. Oops. In here, like y minus 1 equals to 4 times x plus 2. So this is point slope form. If you don't remember, please go back to the previous lectures and go review that. So in here, system of equation, graphing. So given two linear equations after graphing the line. So if two lines intersect, then the point of the intersection is the solution of the system. So okay, so now remember, the graph of this equation is going to be a straight line. So when it comes to a straight line, if you join two straight lines on a coordinate plane, they only have 3 cases, right? They either have one intersection or no intersection, which means they're going to parallel to each other, or they overlap. Let me use different colors pen represent the two lines. So you can see this is two lines, but they are overlap. So let's discuss one by one. Case 1, if there is one intersection, what's that mean? That means for this point, let's say this point is S and Y. This point, since they intercept, that means this point is both on the line, the first line and the second line, right? So that means this point is going to be the solution of this system of linear equations. So basically, because I'm going to say this again, because the point is on both lines, on the first line and second line. So that's why the point is going to be the solution of these two linear equations. Okay, so the second case, if two lines do not intersect, which means they are parallel, they will have the same slope and the different y-intercept. Since they're parallel, they have to have the same slope, but two different y-intercept. Y-intercept 1, y-intercept 2. Okay, then the system have no solution. That means this now, since they don't have intercept, remember the intersection is going to be the solution. Since these two are parallel to each other, that means they have no intersection. That means there's no solution. So the third case is if two lines are the same line, which means they overlap, like what you see on my third graph. So the solution is infinite many solutions on that line. Why is that? Remember I talked about that the solution means the intercept point. Since these two lines are intercept to each other, so that means they have infinite many intercept points, because basically every point they have is intercept each other. Every point that they have is the intersection point. So that means they have infinite many solutions. Okay, so now take a look. Determine whether -2, 3, or 3/3 -1 is the solution of the system. So remember, if they're the solution, that means this point has to be on both lines. So now let's check the first one. We plug in x equals to -2, y equals to 3 into the equation. See if the equation is still valid. So I have the first equation. I'm going to label this first equation, second equation. The first equation is 2 times -2 plus 3 is this equals to 2. So 2 times -2 equals to -4 plus 3. Are they equals to 2? No, this is equal to the left side of the equation equals to -1. The right side of the equation equals to 2. So that means they're not equal. That means the first one, we just need to check once, right? If the first one is not equal, that means the first order pair, they're not going to be on the first equation. That means this is not going to be the solution. Now we're going to check the second order pair. Again, we want to check if these points are they on the first equation and the second equation. So with 3/2, so 2 times 3/2 plus -1, we don't know if this equals to 2. We're checking the first equation. So now I have 2 and the denominator, they cross cancel each other, plus -1. So now I have on the left side of the equation, I have 3 plus 91 equals to 2. Okay, so they're equal. So that means the order pair is on the first equation. We still need to check if they're on the second equation. So now I'm going to check the second equation. Again, I have 4 times 3/2 minus 3 times -1 if this is equal to 9. So I have here 2 times 3 equals to 6. -3 times -1 is negative. So this gives me a +3. Wow, the left side of the equation equals to 9. The right side of the equation also equals to 9. That means the second order pair also on the second equation. So that means the second pair, the second order pair is the solution of the system. Okay, so now let's try to solve the system by graphing. Okay, so how do you remember how to graph? We can make a t-table. So again, I'm going to label this 1 and 2. For the first equation, I'm going to use different color pen for the second one. For the first equation, I have x plus y equals to 1. So now I want to know x equals to what, and then I can make x plus y equals to 1. And then I have my order pair s and y. Let's say if x equals to 0, so I have a 0 plus y equals to 1. So y equals to what? Y equals to 1. So my order pair is going to be 0 and 1. Okay. The second one, I want to pick 1. If x equals to 1, 1 plus y equals to 1. So that means I solve for y equals to 0. Again, you can pick any number. The reason I pick 0, 1 because it's easier for me to calculate. So I have the second order pair is going to be 1, 0. Now I label it on the coordinate plan. 0, 1 in here, 1, 0 here. So now connect these 2 points together. I got a straight line. Okay, not very straight, but it's a straight line. Okay, we found our first line. So now let's try to draw the graph for the second one. So again, we use the t-table. We have a negative 2x plus y equals to 7. So I have x, negative 2x plus y equals to 7. And we want to find out the order pair. When x equals to 0, we have a negative 2 times 0 plus y equals to 7. Well, I found out 7 is equals to y equals to 7. That works. However, this is outside of the coordinate plane because the coordinate plane is, the range of the coordinate plane is from negative 5 to 5. That means we can pick 0. We should pick something else. So now we can try x equals to 1. When x equals to 1, I have a negative 2 times 1 plus y equals to 7. And then we solve for 7. Solve for y. So y is equal to what? 9. Well, still doesn't work. Well, we try something else then. Let's try x equals to negative 1. So I have a negative 2 times negative 1 plus y equals to 7. Well, negative 2 times negative 1 gives you a positive number, which is 2. 2 plus y equals to 7. So y is equal to 5. So my order pair is going to be negative 1 and 5. Okay, and next order pair, it seems we want to pick something a negative number. Otherwise, it's not going to be on the coordinate plane. So let's pick negative 2. If x equals to negative 2, so when you solve it, we have 4 plus y equals to 7. So y is equal to 3. With a negative 2 and a 3. Okay, we found 2 points. We label it on the coordinate plane. Negative 1, 5, positive 5. And then negative 2, positive 3. So we have that. So this is the plan. So where's the solution? The solution is going to be in the intersection. It's going to be here. So here is the solution. So so the solution is going to be the intersection, right? Which means it's on the point what? When x equals to let me see, when x equals to negative 2, y equals to 3. That would be the solution because that's the intercept point. Okay, we use the same idea to do another example. We have x minus y equals 1. Again, we make a t-table chart to find out what x and y equals to and find the order pair. So when x equals to 0, I have a 0 minus y equals 1. So y is equal to what? 1? Wrong. Y is equal to negative 1, right? Because when you're subtracting them, you have what? Negative 1 equals 1. So y is equal to negative 1. This is a tricky part. 0 and negative 1. Again, the second one, I want x equals to 1. If x equals to 1, 1 minus y equals to 1. So y is equal to 0. So I have a 1, 0. Okay, now I have a 0, negative 1, and 1, 0 here. So this is going to be my graph. Okay, after we find the first line, I'm going to use a different color of pen to find the second line. I have negative x plus y equals to 3. Again, we made the t-table with a negative x plus y equals to 3, x and y. When x equals to 0, I have a 0, negative 0 plus y equals to 3. So y is equal to 3. I have a 0 and a 3. I label here 0 and a 3. It's on the y-intercept. And now I pick another one. X equals to 1. I have a negative 1 plus y equals to 3. So I add 1 on both sides, so y is equal to 4. So I have 1 and 4. So 1, 4, which is here. So now let's take a look. I extended these two lines. Oh, what happened? This is a parallel line. Remember, when they parallel means they have no intersection. That means there's no solution for this system of equation. Okay, next one. Negative 5x plus y equals to 2. Again, we made the chart. Negative 5x plus y equals to 2. I have I pick random number for x. Negative 5x plus y equals to 2. And then x and y. Okay, x equals to 0. I love picking 0 because that's easier for me to compute. And then negative 5 times 0 plus y equals to 2. So y is equals to 2. So I have 0 and the 2. So the second one, I'm going to pick negative 1. So I have a negative 5 times negative 1 plus y equals to 2. Negative 5 times negative 1 equals to 5. And then you subtract 5 on both sides. You will have a y equals to negative 3. So I have a negative 1, negative 3. So 0, 2, negative 1, negative 3 here. So it's going to be here. Now the second line. I am going to use a purple one. I have negative 15x plus 3y equals to 6. So I have x, negative 15x plus 3y equals to 6. X and y. So if I pick x equals 0, I have negative 15 times 0 equals to 0 plus 3y equals to 6. So y has to equals to 2. 0 and 2. Let's see. If I picked, again, any number, let's pick negative 1. So I have a negative 15 times negative 1 plus 3y equals to 6. So here I have 15 plus 3y equals to 6. Subtract 15 on both sides. I have 3y equals to negative 9. So you divide it by 3 on both sides, you have a negative 3. So that means the other order pair is negative 1 and negative 3. Uh-oh. They are the same. When I connect them together, you should get the same line. So this line is overlap. They are the same line. Means what? They have infinite many solutions. Because all the points are intercepts. All the points on the lines are intercept. Okay, that's it for today. Let me know if you have other questions.